Now, in the last video, we were discussing the ETL pipeline, what it stands for. E stands for extract, taking data from source, extracting the data from CSV files, JSON files, Excel files, or from API or database. Then transforming the data, that is cleaning data, for example, removing nulls, removing duplicates, uh, uppercasing the names, and calculating salary, changing date formats, you know, to basically have a standardized information for using in the next step. And then loading is storing this processed data. For example, in SQL Server or Snowflake, Delta Lake, Azure, or Amazon S3. So basically from CSV to Spark to Delta table. That's basically ETL, extracting, then transforming here, and then loading. For example, suppose an online shopping website records every purchase. We have this as the raw data. Now we extract. So we read the CSV into Spark, and then we transform. Remove the duplicate order IDs. Here we have one or two duplicate. Standardize the customer names. So uppercasing all these names. Removing the rows where the customer is missing. So customer is null here, so that is missing. So this is the result, right? Now loading, write the clean data into a Delta table for reporting. Now we are discussing ELT versus ETL. So modern cloud systems often use ELT, that is extract, load, transform, rather than extract, transform, load. So that's basically cleaning the data. ETL is basically cleaning the data before loading it, right? Because we transform the data before we load it in ETL. But in ELT, we go from source, load it into the storage system, and then transform. So we first load the raw data into a scalable storage system like a data lake, and then transform it later using Spark or SQL. Why do we do this? This we do because cloud storage is cheap, and you may want to preserve the original data that you had for auditing or future use before you actually transform it. So we load the data first, and then we make changes, then we transform, then we basically do our data processing, pre-processing stuff, steps like cleaning or removing null values, removing duplicates, so that we can store it for future use, the original data. Now, what is big data? It doesn't just mean a lot of data, it's data that traditional tools struggle to process efficiently. The 5 V's of big data: first is volume, massive amounts of data like in terabytes or p-bytes. Then velocity, data arrives quickly, stock prices, IoT sensors. Then variety, structured, semi structured, and unstructured data. Then we have veracity, that is data quality and reliability. And then we have value, the useful insights that you can extract. Now, why traditional systems struggle? Imagine processing 10 terabytes of log files on a single laptop. Problems would be not enough memory, CPU becomes a bottleneck, processing takes days, hardware failure can stop everything. This is where distributed computing comes in. So, what is distributed computing? Instead of using one computer, we use many computers working together. So, we distribute the process, the tasks. Imagine you have to count the words in 1,000 books. One person reads all 1,000 books, time 100 hours. 10 people, each person reads 100 books, time around 10 hours. So, the work has been split across multiple workers. Spark follows the same principle. Now, why Apache Spark was created? So earlier, we'll be getting into some history here. Earlier, Hadoop MapReduce processed large data sets but wrote intermediate results to disk after almost every step, making it relatively slow for many workloads. Spark keeps much of the working data in memory, reducing disk I/O and often speeding up iterative algorithms and interactive analysis. Spark also provides high-level APIs for SQL, streaming, machine learning, and graph processing, making it easier to build diverse data applications on one engine. So now we have this as the summary. So we have understood what is data and information, what is the difference between structured, semi-structured, and unstructured data, why we use databases, what SQL is, difference between ELT and ETL, and why technologies like Apache Spark have become necessary. So we'll